Okay, today we are covering angled launch. Before you cover this, make sure you've seen the last video. If you do not, you'll be really lost at what we're doing. You need to have a lot of practice with projectiles before you begin. So angled launches. It's also referred to as ground to ground. It's where we're going to be shooting a projectile off the ground, launching at an angle, and it's going to return back to the ground. The X direction is going to be the same as horizontal launch. However, our Y direction is going to be different, but it's going to look very similar to the problems where we threw a ball straight up and back down in kinematics in our first unit. So some key things here. The time to the top is half of the total time. So obviously we can split this problem in half right here, just like we did with the kinematics problems where we threw a ball straight up, and we're gonna have a lot of the same things. The time to the top, so to this top point, is gonna be half of the total time across the angle launch. At the top, as you can see, as we go up, our velocity is decreasing, but it's always positive on our way up. Then we hit the top, and then all of a sudden we start moving back down, which means our velocity is negative. So at the top, we have a velocity in the Y direction of 0. Of course, our velocity in the X direction is always some positive number. It's always positive, because since we're moving forward constantly. The velocity in the Y direction at the start is going to be equal to the velocity in the Y direction at the end, but the negative version, because at the very end, of course, we're still moving to the right, but we're also moving down. Delta Y to the top, so our distance in the Y direction to the top is going to be equal to the direction, our displacement down to the bottom. And of course, our acceleration is 0 in the Y direction. And so, as you can see, since this is very similar to the problems we did last unit, it's going to be very useful oftentimes to cut the problem in half and work with only half of this problem. And if you do that, it turns out that this is just a horizontal launch problem. If we work only half the problem, if you see this right half, it's just a horizontal launch. And so if we're able to cut the problem in half, then it makes our whole lives easier, because we're just working the same thing that we did last class. Okay. Additionally, and this is the big difference, is that we have a launch, which means our initial velocity is at an angle. And so we have to split up our components. And so here's the equations we're going to be using to do so. If we have an initial x velocity, it's going to be equal to whatever our initial velocity is cosine theta. Our initial y velocity is going to be equal to v naught sine theta. And then, of course, the total velocity is equal to the, as we use Pythagorean theorem here, the x component plus the y component squared, take the square root. Okay, so let's actually do some practice problems. This is the one I recommend doing as many practice problems as you can. Please, if you can, look up on other online resources that can help you out on this one, because this is probably the most confusing problem out of the two. Mario lobs a banana at an angle of 30 degrees and with a velocity of 16 meters per second. How far does the banana go? So we draw a picture. We have a banana. It shoots off at 30 degrees with a velocity of 16 meters per second. And we want to know how far it goes. So we want to know the delta x. So we can draw our t-chart like normal. Delta v naught VFAT. We can fill in what we know. And because it's not a horizontal launch, we don't get to fill in this part like we did last time. We used to fill in 0 here. It's not a horizontal launch, so we can't do that. Okay, what else do we know? We know our V naught is 16 and our angle is 30 degrees. That is not anything on this chart, because this V naught is in both directions. It's in the X and it's in the Y. And so we can't fill it in here just yet. However, we can find V naught in the X direction by doing V naught cosine theta, which is 16 cosine 30. So you put that in your calculator, you're gonna get 13.86, and that you can plug in for our Y, 13.86. And you can do the same thing for the Y direction. And again, if you plug that into your calculator, you should get 8. Okay. So how do we figure out, So how do we figure out more information? Because in order to solve any side, we need at least 3 pieces of information. But right now we only have 2 pieces of information. Well, that's when that distance to the top comes into play here. I want to figure out the time to the top, and if I can figure that out, then I know the time for both of these spots is going to be 2 times that. So let's think about just at the top in the y direction. So I'm going to write y top here as a separate column. Okay, y to the top, our displacement, we don't know. Our v naught is the same thing, it's 8, because we're talking about right here. Our initial velocity is 8 in the y direction. Our final velocity is 0, and that's why we did this, because we have an extra piece of information. We know at the top our y velocity is 0. And acceleration is -9.8. Our time is equal to, we don't know yet, but we can find it, right? Now we know that Vf equals V naught plus AT, and this can be solved. -8 divided by -9.8 gives us a time of 0.816. And we know that's the time to the top, which means the total time is 2 times that, which is 1.633. And now we can use our other equation on the x side. Delta x is equal to V naught t. Delta x is equal to 13.86 times 1.633. Multiply them in your calculator and you get 22.63 meters. And that's our answer that we want. That's our displacement. So as you can see, it's going to take more thinking. It's going to take more work on this one. So it's going to take more practice for you to get used to it. Let's try a different one. Luigi launches a Molotov back at Mario. He's at the same distance at 23 meters, but his throw is in the air for 2 seconds. What was his initial velocity and launch angle? Okay. So let's again start with what we know and fill in our table. We, of course, know our accelerations. We know our time. And we know the distance 23. Okay. So with this, we can find initial velocity, which is nice. But I can't find the initial velocity in the y direction just yet. So let's go ahead and find V naught in the x direction to start off with, since that's what we know we can do. We know delta x is equal to V naught t. We know 23 is equal to V naught times 2. And so 23 divided by 2 gets us 11.5. Perfect. Okay. So we know the velocity in the y direction, or in the x direction. How do we find the velocity in the y direction at the start? Well, again, we're going to split this problem in half. So let's do y to the top again. So again, we're thinking about this motion from the start to the top. Again, we don't know delta here. We don't know V naught here, but we do know Vf is 0. We know A is -9.8, and we know the time is 1 because we're going half the time. The total time is 2, and so halfway, which is to the top, is only 1. So now we can find V naught. Vf equals V naught plus AT. To find V naught, we just do Vf minus A times T. So we get V naught equals 9.8. Okay, we are almost there. So let me draw a picture so this makes sense. We are shooting the Molotov at an angle, and it has 2 components because it's a vector. Any velocity is a vector. It has a component in the x direction, that's 11.5, and it's a component in the y direction. That's 9.8. Therefore, to find our magnitude and to find our angle, to find v naught, we're going to do the square root of our x component squared plus our y component squared. And to find our theta, we're going to do inverse tangent of our y over our x. We're doing our vector stuff. Our vectors are never leaving us. If you're still struggling with vectors, you need to come to tutorials. You need to get help. We need, especially for next unit, it's going to only get more intensive with our vectors. Okay, and so this can be solved. 11.5 squared plus 9.8 squared, square root 15.12, and our angle, inverse tangent 9.8 divided by 11.5 is 40.4 degrees. And with that, we have our V naught and we have our launch angle. Next time we'll talk about projectiles conceptually, so we'll continue the notes. Let me know if you have any questions and get started on the homework. Thank you.